So the problem we have here is you are given a function f of x, which looks like that, and you are supposed to discuss how to analyze my function being concave up, concave down, or having an inflection point. We're going to mention the definition a bit. So to discuss concavity, you should realize right away I'm actually asking you something about the second derivative. So let's go ahead and calculate the derivative. It's x squared plus 4 to the power of negative 1. Take derivative. Of course, you could have used quotient if you want to, right? Either way works. I personally prefer chain rule for this case. So I have negative 2x over x squared plus 4 squared. And it's not over yet. I'm looking for second derivative. Now you can either refreeze it or you can use quotient rule. So I have negative 2 times x squared plus 4 squared minus negative 2x times twice of x squared plus 4 times 2x over x squared plus 4 squared. So this is me using quotient rule. So I have a negative 2x squared plus 4 squared minus, that's a plus, 2 to 2, that's an 8x, that's an x squared. So this is what I end up with, x squared plus 4 fourths. So it's quite obvious that x squared plus 4, x squared plus 4, and 2, they are shared expressions in both pieces. So what I'm going to do is I'm going to factor it out. So I first pull out a 2x squared plus 4. And then what's left from the first term is a minus and another x squared plus 4 because it was square originally. The 8 factor out this 2, it's 4. X squared is not touched. The x squared plus 4 is already been factored, so it's nothing left. So I have x squared plus 4 to the fourth. You could simplify it because this is one thing, so you have minus 1 here. So you end up with twice of negative x squared minus 4, minus plus is minus, plus 4x squared divided by x squared plus 4 cubed. So it's twice of 3x squared minus 4 divided by x squared plus 4 cubed. So this is what? This is my second derivative. When I try to decide whether it's concave up or concave down, I need to decide when would this expression be positive or negative. So when I try to discuss 2 times 3x squared minus 4 divided by x squared plus 3 cubed, you probably have realized the sign, the positive and negative property of it is independent of this 2 because times of 2 doesn't change the sign of it. So those two expressions, they share the same sign. They will be positive at the same time. They will be negative at the same time. Just like x and 2x, they are both positive whenever you choose x being positive. They are both negative whenever you choose x being negative. So they always share the identical sign, being positive and negative at the same time. And along the same line of thinking, I'm going to make the same comment. I can ignore this term here. So what am I talking about? I'm talking about 3x squared minus 4 and 3x squared minus 4 divided by that. They share the same sign because x squared is greater than or equal to 0. X squared plus 4 is always positive. X squared plus 4 cubed is always positive. You have an expression divided by something that's guaranteed to be positive, then the sign of it is always the same as not dividing the same thing because the denominator will never change the sign of the expression. So that is to say, if you want your second derivative to be positive, then you want 3x squared minus 4 to be positive because they always share the same sign. Along the same line of thinking, okay, by the way, this is concave up. And along the same line of thinking, if you want the second derivative to be less than 0, it means your function concave down, that is to say the sign of 3x squared minus 4 is less than 0. So 3x squared minus 4 is the key factor. Right, inflection points is where your second derivative changes its sign from positive to negative. And as you can tell, the sign is the same as the sign of 3x squared minus 4 and f double prime. So it's just a matter of discuss the sign change of 3x squared minus 4. Okay, so hopefully this helps you to answer the question properly.